All right, thank you for coming to my talk. So, short about me, my name is Emil. I'm the head of product security in FINN.no / Schibsted marketplaces. And Schibsted marketplaces is an entity that owns like several similar marketplaces like Finn in the Nordics. So today I'm going to talk about from DevSecOops to security success and the bug bounty effect at Finn. And I realized that there are some people in this audience that don't know what Finn is. So in Norway, everybody knows what Finn is because it's the most popular marketplace. And it's basically a simple web page where you can buy and sell almost everything: your house, car, shoes, mobile phones, etc. So it's basically a simple web page like this. And this web page is basically consists of about 1,100 applications doing various stuff. I think we have over 250 ingress endpoints in Comparative, and then we have way more exposed APIs, right? And back in the day, we used to have like 200 developers, but after the reorg, this Nordic reorg, we are more like 500 developers. So that is sort of the scope of the whole organization, but it's not only Finn. And these developers are quite effective, I would say. So they can choose any language and any framework they like when they build their applications. And that, of course, has a bunch of security implications when you try to roll out code scanning, for example. So hard to find tools that fit. And they can basically choose whatever language they like, as long as they can package it as a container and then deploy it in the platform. And of course, that gives you a very nice attack surface, and there's also a high chance of having vulnerabilities in production, right? So this is the DevOps lifecycle. This has been the de facto thing for about a decade. Everybody is following this now. So it's basically, the premise is that the developers should be able to deploy their applications and not only build them and code them. So they deploy them themselves, and then they monitor them and operate them in production. And of course, the security community wanted to join this movement, so we created something called DevSecOps. And I guess my definition of that is just sprinkle some security activities across the different phases, and then you get more secure. And of course, some of these activities are not specifically tied to a phase. For example, threat modeling can be done at any time, whereas pen testing and bug bounty programs are more usually done when things are in prod. And DevSecOops is what you get when you try to do this at some scale, and you just realize that you are drowning in false positive alerts, just spamming your developers with noise, basically, and you're just doing busy work and not actually reducing your risk. And in Finn, we have a bunch of vulnerability sources. So for code, we have advanced static code analysis with CodeQL. We also check for dependencies and the secrets. On the dynamic side of things, we have a web app scanner, Detectify, which scans us 24/7. And that also does some attack surface monitoring, finding subdomains, etc. And then we have a bunch of cloud security tools. On the manual side of things, we have the traditional pen test and also bug bounty programs. And the last box is basically any internal finding. So that can be sourced from a developer or a security team doing, for example, threat modeling, pen testing, or just code review. So we try to track these different sources to benchmark them against each other. And some of these sources, they produce a lot of findings. But the findings we care about are basically those that are verified to be exploitable in production, so a verified vulnerability. And as you all know, like these automated tools, scanners, they produce a lot of false positives, noise, and also findings that might be technically correct, but not exploitable when they are in production. So we try to focus on fixing what is actually exploitable to reduce the risk. These are some numbers from the number of verified vulnerabilities we found in 2019. So we had Detectify, found about 16 cross-site scripting, so easy, low-hanging fruits. We also had 3 different pen testing engagement with 3 different vendors. They found about 19 vulnerabilities, so not that much. And then the internal findings, basically me and a few developers just doing ad hoc testing, found about 29 vulnerabilities. And then we launched a private bug bounty program in September. And that activity almost found more vulnerabilities than all the other activities combined. So that was quite impactful. And the one activity we have been doing for all the years is basically pen testing. And back in the days, way before the DevOps and rapid releases, we basically just released quarterly or once or twice a year. And then we had something called a release test, which of course makes a lot of sense. You test everything before you push it out to prod. But when we started to move more rapidly to release, I don't know, several times a week, 100 times a week, then that doesn't really scale. So you cannot have a pen test for all your push to prod, right? So from 2014-18, we had something, we had a monthly, or we had 2 larger pen tests every year, which was basically maybe 2 persons for 1.5 weeks, 2 times a year. And that doesn't really scale with thousands of deployments per week. So the vulnerability forecast is basically, it's quite foggy, and there's a high chance that we have undiscovered vulnerabilities in prod because we're not really testing all the changes that goes out to production all the time. And this is basically what I found when I started in FINN in 2019. So I tried to calculate the average exposure time of all the vulnerabilities we found, and that was 800 days on average, meaning like almost 3 years before they were discovered and fixed. And the oldest finding, which is a big oops, was almost 11 years in production. And that's almost like having a teenager vulnerability. And that's not something you would like to have. You would like to have like baby vulnerabilities that is like a month old or something. When we look at the discovery, so these are numbers from the 2 pen tests per year we had from 2014. They found about 15 findings on average, and the cost per finding was quite high. And when we look at the types of vulnerabilities we found in that time period, most of it was, of course, cross-site scripting. And then we had like 6 other type of vulnerabilities. So where are the remote code executions? Where are the server-side request forgeries? I'm sure we can produce those vulnerabilities as well, right? Because they are in the OWASP top 10, etc. So after we launched the bug bounty program, we got what I call the bug bounty effect. So we basically got way more diversity in the findings. And the simple reason for that is now we had a lot of people looking at the site every week instead of once or twice per year. So we get more eyes on the target. And yeah, what's a bug bounty program? I like to think of it as crowdsourced security testing. So we host it on a platform, and then the hackers get invited there. They can read the scope, and then they can start hacking us. And when they submit a report, we pay for the findings that we deem valid, that we want to fix. And we set the severity based on the impact it has, basically. And programs are usually public or private. We have been private all the time to try to keep the report quality up. And it's also you as a company that will set the scope and the behavior of the hackers. So for example, we have most things in scope, but we have some rules that they should not send messages to end users because that is noisy, right? And they are also not allowed to click that button to trigger an invoice for a random company in Norway, because that happened several times. And of course, the benefit includes that you get more continuous like testing, you get more findings in total, but also more diversity in the findings. So you get all the vulnerabilities you would like to find. And for us, we test only in prod, so it's good for testing any end user facing service. But we cannot really test like the bank ID verification flows or back office and admin interfaces. So for those use cases, we still do the occasional pen test. So yeah, they both have their valid use cases, I would say. A question I get a lot is, how much do we pay? So we pay the hackers based on the severity and the business impact. So basically, any of the classical SQL injection, remote code execution, data leak stuff is, of course, critical. But for the marketplace, it's quite important that we don't have any fraud there. So anything that can leak, for example, user emails, disclose phone numbers, or if you can do account takeovers, that's very important. So those are critical for us. And we started at $100 to $3,000, and now we are at max $6,000. It might seem a lot in a Norwegian context, but if you look at the bigger pictures, the big tech companies, they pay like way more for the critical bounties. So like Shopify and Google have like hundreds of thousands of dollars as their maximum bounty. And we have in total only paid $200,000 in 5-6 years. We also see that the median bounty is about 200 to 400 for the last few years. So it's quite effective. But since we cannot really compete with the big tech companies on the bounties, we can compete on other factors. And a wise man once said, it's nice to be important, but it's more important to be nice. And that's basically what we're trying to do in the program to attract bug bounty hunters. So by being nice, I mean that we are friendly and respectful in the messages. We're also quite lax on the scope definition. So if you submit something that is out of scope or not listed in scope at all, we will accept it if it has impact and then add it to the scope. Whereas other programs might not accept it and then go and fix it. And that's a very bad practice because you're basically stealing from the researchers and not paying them. We also try to pay fairly, so we work with hackers to determine the maximum impact instead of trying to limit the impact all the time. So that has happened many times, that we increase the severity, and then, of course, the hackers get happy. We also have cases where they submit reports that are not really critical, and then we can lower them. But it goes both ways, basically. And I think the most effective thing is basically to be fast on the response time. So back in the day when we were at HackerOne, we were faster than the top 20 programs on HackerOne. And the reason we could do that was basically we didn't get 100 reports per day. We got maybe a few every week, right, or some every day. So it's not that easy, or it's very easy to keep up with. And that can be very motivating because some programs, they have very long time to verify the reports. So the hackers in the report, they might wait a week, a month before they get the final decision, whereas if they get the response within the same hour, they get happy like this. So this guy, he got very motivated and wanted to look more on the program, and that resulted in that he was the top 1 hacker for us that year. So he earned a lot of money, and we got a lot of nice bugs. So nice collaboration there. If you dig into the response times, so in the beginning, it was quite slow, 21 hours on average and 2 hours on median. And the main reason for that is when you start the program, this will be new for you. So it takes more time to figure out what you should pay and what is the real impact. And of course, this graph is the number of submissions per quarter. But for the whole year for 2020, we had over 280 reports, and the time to triage there was like 4.5 hours and 18 hours in median. And that's insanely fast, but that also kept them motivated to work on the program. This is a story of a critical fix on a Saturday night. Some of you might know Spring Boot and the actuator endpoints, which basically can give you a lot of juicy information. And we had this HTTP trace endpoint, which will basically show you other end users' requests. And that means that you can basically create stealer cookies and do account takeover. So if the fraudsters had found this endpoint, they could probably create an account takeover as a service because they could automate it. It was in JSON, right? So quite nice vulnerability. And this came in at a bit over 9. This was a Saturday, so I was watching TV, laying on a sofa. So I didn't really react immediately. But eventually I did, and I verified the report quite quickly. And now I had this dilemma. Who should I talk to? And how can I reach out to some people outside of working hours? I was quite lucky because one of the principal engineers, or I guess all the developers in Finn, they have access to this platform, and they can opt in to get notifications. And a lot of these developers think it's quite interesting to follow along. So he was actually deploying this fix while I was verifying the vulnerability. So it's almost a race condition there. And then we closed the report, and then we got the happy hacker. So this is the same graph as before, only zoomed out per year. This is the number of submissions. So we can see it's a classical roller coaster. The first year was quite busy. So yeah, we got a lot of reports, but those are not the valid reports. That number is, of course, a bit lower. But as you can see in the beginning, almost all the reports were valid. Then we had a bigger gap in 2020. But for the rest of the years, it has been very closely, except the last year. And speaking about money, the first year we paid about 15K for 24 valid vulnerabilities. That's cheaper than a pen test, but way more vulnerabilities than we got for 3 pen tests the first year. So quite effective. And then the other years also not that expensive. So what are the other types of reports we are getting? Well, the ones that we are not accepting for various reasons. It can be that they have no impact, and there's stuff that we don't want to fix, then they are not accepted. And that has also been quite low, but in 2024, we basically had very low activity in the program, so only 44 reports the year before. So we started to invite more hackers at random. So we are a private program. So we started to invite 100 hackers per week, and then we saw a good increase in the number of reports, but the quality was not improved. And I think that we are also seeing the same from the other tools we have. So the scanners, they are also finding less vulnerabilities. So I think we're sort of a hard target at the moment, but still, when you add 100 random hackers per week, it gets more like a public program, I would say, in the report quality. And speaking of report quality, running a private program helps, but if you invite random hackers, then you get less quality reports. And I would say closing bad reports is not a big time sinks. Sometimes it can be fun. For example, this one. It was a cross-site scripting through the DevTools or the web browser console. So the vulnerability just paste this JavaScript in the console and you get a pop-up. So like I guess some people believe this, but yeah, this is more self-side scripting, I would say. And like I would say, there is 3 degrees of low-quality reporters. You have the one we just saw, where we say, OK, no bounty, and they accept it. Then you have the guys that do not accept it, and they start to argue with you. So they beg for a bounty or a positive close status, and that means that they don't get negative reputation points on the platform. And then you have the guys that don't really accept it at all. So they start to send you threats instead by, we're going to disclose this publicly, etc. And that has only happened to us once, and I will show you that in a minute. But first, we need to talk about denial of funds attack. So the platform we are on right now, we have usually about 10K euros in the bounty pool, because average bounty is about 400, right? And they will auto-suspend the program if the bounty pool is depleted. And they also reserve the bounty amount when a report is received, so before it's verified. So let's say somebody sends you 3 criticals that are just spam, then they will close the program. And that's an issue if that happens on a Saturday. And guess what happened? So we got 3 high-severity reports on a Saturday. The program was auto-suspended. I had to do something. And when I looked at those, 2 of them had almost the same title. They had the same content, but different order. So that was kind of strange. And they were also reported with different severity. But it was the exact same domains and stuff they listed there. And that had basically no impact whatsoever. So he basically found some old domains on our GitHub. They didn't even exist in DNS, so there was nothing there. So this was closed as not applicable, just to get this out of the way. And this is a closed status we rarely use, because we try to be nice, right? But this was just spam, so yeah, let's close it as not applicable. And then he got back to us, so he basically threatened to go public on Twitter, so that we will know the opinions of the other people that my decision was wrong. And of course, since this was a Saturday, I didn't want to sit on Twitter and argue with the bug bounty mafia. So I just closed this as not accepted instead. So we could just get it out of the way. But so this has only happened once, so this is not something we deal with a lot. But sometimes we also get reports in funny formats. So one time we got a report by just meme pictures. And as you can see on these pictures, it's quite dated format. So it's basically from 2019. So this was by a Finnish guy called TK0. And he liked the program, and we had a lot of fun in the comments. So this bug was basically that you could screenshot the app if it was sent to the background from other apps, because we didn't blank it out. So not high severity, but he got a bonus for the effort. So the impact for us has been that we have found and fixed a lot of old vulnerabilities, and now we're also finding vulnerabilities much faster. So there is no more 800 days in prod. It's more like weeks, months instead. And that's very good. We also see that the number of findings are decreasing. That might be because the program have worse researchers now. But if you compare it to the other tooling, they're also finding less stuff. So I like to think that this is because we are more hardened now than before. And of course, it's more effective in terms of money. And a fun fact here is that out of the 360 reports, only 2 were caused by a so-called vulnerable dependency, open source dependency. And the first one was a random cross-site scripting, which was found independently of fingerprinting the application and figuring out if it had any vulnerable dependencies. And the other one was, of course, log4shell. So I think this says something about the importance of always focusing on having 0 vulnerable dependencies, because they are very rarely exploitable in my experience. Of course, it's a best practice, but it's like I think it's better to focus on fixing the bug in your the bugs in your own code, because they are also there, right? But they are not really surfaced. Another nice side effect of this bug bounty program has been that it has been basically the key ingredient in our AppSec program. So when all the developers got access to the platform, they were basically able to follow along on the reports. They talked about it in the office, and that led to some security vulnerability awareness that we didn't have before, right? So that was a nice side effect. And also with this much data, we can also use that to steer our efforts. So for example, we have a lot of XSS, then we should focus on fixing that problem. But we have not had a SQL injection since 2014, so that means that we shouldn't probably train the developers a lot in that, because for us it's a solved problem. And the reason for that is that we didn't have any security people working here in 2014 either. So this basically happened organically. And the main reason is that the main programming languages we use, like JVM stuff, they have for years used secure defaults when they build database libraries and wrappers. And that basically means that they automatically encode any input, so that the developers do not need to manually remember to do it. Because if that's the case, then you will always forget it, right? Not always, but people will forget it. And you might say that we haven't looked close enough, but 10 years of pen testing, 5 years of bug bounty, a lot of other tooling has never found, or at least in the last 10 years. We also did a bug bounty promotion campaign. So we basically paid double amount for SQL injections, but still no findings. So I would say that secure defaults are so-called certified DevSecOops. So you remove the bug class instead of finding individual bugs after they are created. So code scanning, all the scanning tools will find the bugs after they are created, if they find them. Yeah, so that's the most effective thing we can do, I think. We also are weaponizing the vulnerability data, meaning we are using it to create training or CTF challenges. So a couple of years ago, we created about 35 challenges and had a CTF, and those challenges were based on the findings we had in the bug bounty program. So for us, it was quite fun and also very engaging for the developers. And our strategy was basically to release a few challenges per week until the main event. And that kept them very engaged, because if you solve a challenge first, you will get more points. So quite fun exercise. But even though bug bounty by far has been the most effective thing we have done in terms of spending, but also in terms of number of vulnerabilities, we still do all the other stuff. Like we still do code scanning, we still do dynamic scanning, and a bunch of other stuff. And the reason for that is these tools find different types of vulnerabilities. So there is no overlap, or there is a lot of overlap, but they all find specific things. So all in all, this will give us better assurance, I would say. And a fun fact here is that out of the 20 critical bugs we have had in the program since 2019, only 5 of those could have been found with code scanning. And that basically means that if we had 100% coverage with code scanning everywhere, we still wouldn't have found those 15 other critical vulnerabilities. But when you have both, we find in total more bugs. So now it's time to compare apples to oranges. It's not a fair comparison, but it's a fun one. So I have a lot of experience with rolling out CodeQL, and that requires you to basically build your application if you have compiled languages like Java, C#, Kotlin, etc. And that requires you to basically, you have to run it in CI/CD, and then you have to edit those files, and then there's a chance that you might break the build if there's a bug there, right? So for us, it took a lot of engineering effort to roll this out without pissing the developers off. And then when you get findings, these findings lack context. So even though it's a technical correct vulnerability, it might not necessarily be exploitable. So it can be a bit noisy and stuff that you don't want to prioritize. And of course, high cost and no guarantee for finding all the things. Then we have the bug bounty program. It's basically scope once and hacks everywhere. You get a lot of real findings. And for the developers, they only interface with the real findings. So for them, they have more trust to that because they know that if it's coming from the bug bounty program, they know that this is externally exploitable. Yeah. So that traditional advice has been that before you launch up a bug bounty program, you should do all the things. You should do threat modeling, code scanning, dynamic scanning, etc. But if you have a quite large organization, this will take years to do it properly. So my spicy advice is basically don't do that. Just launch a private bug bounty program and do some real risk reduction. The only requirements is that you need to be able to receive reports, and then you need to be able to fix them within a reasonable amount of time so you don't drown in duplicates. And yeah, I think you will see the effect quite immediately when you launch a program. Another fun comparison is basically security.txt versus bug bounty. Also not a fair comparison, as you can see. And security.txt is basically a text file you put on your web page where you have some information about how they can test your site, but also how they can report bugs. And over the years, we have had very few findings. Most of it is just spam, but we also get very few emails there. And then the bug bounty program has given us a lot of reports, as you see. But the fun thing here is that I've actually gotten more real findings through LinkedIn than through security.txt. So LinkedIn for the win. But that's not really the pointer. The point is that all companies of a certain size should have a bug bounty program because that is where your real bugs are going to come. And there is a lot of Norwegian companies that don't have bug bounty program, but they do have security.txt, and I think that's the same thing. And that's not the same thing. So pay your hackers, and then you get more findings. So now I'll try to sell you bug bounty for a while and the effects of that. So now I'm going to show you how to launch one. And it's quite easy. Just get some money, and then you find a platform. And I would recommend you to just test different platforms, see if the features are OK. They will also try to sell you managed triage services. But if you buy that, you'll be as slow as everybody else. So I recommend doing that yourself, because then you will have happy hackers. You will also need to set your bounties based on your business impact. But so my tips there is basically get inspired by other programs to align, basically. And then when you are going to scope it, start small and then expand as you mature the program. Some people recommend doing pen tests before launching. We did 3, and for the year after, we found over 170 new vulnerabilities. But I guess we did find something in the pen test that wasn't discovered in the bug bounty program. So yeah, doing them all is, of course, better. Then we, of course, do 24/7 scanning to catch low-hanging fruits and also to compare the different security tooling against each other. So whenever we get cluster scripting reported to the bug bounty program, we go and check, is this app scanned by code scanning, and why wasn't it found? Because then we can benchmark, basically, if the tools are doing their job. And then the last part, you need to inform your org about it. There will be a lot of scanning noise, and you need to give access to the platform to the developers, etc. And then you can build some security culture for free. Now I'm going to talk about some platform must-haves. And of course, single sign-on, I'm not saying that because it's the best practice and it's secure. I'm saying it because it's very annoying to manually give access to users. And you want the developers to have access to the platform seamlessly. And some of this platform will tell you that you can import it to Jira instead. But as you all know, viewing a vulnerability report, quite a long one with requests and stuff, it's quite painful in Jira. So then you will get a Jira headache, and that's not something you would like. So yeah, that's a must-have that you should be able to easily give access. The second one is to have a good API. And by good API, I mean it shouldn't be painful to use, no silly rate limiting or auth methods. You need to be able to import reports, because when you find stuff with your other security tooling, you would like to import them so you don't get duplicates, or so you can close them as duplicates when the hackers find them. It's also nice to be able to export the data if you have a third-party system where you have all your vulnerability data. And also, it's nice to crunch the metrics yourself sometime, because this platform often doesn't have the numbers you are looking for. And then, of course, you can also automate the missing things. So one of the things that we can do, but we haven't done yet, is to basically be able to auto-assign our incoming report to the correct team, because we have tagged all the Kubernetes deployments with the team and the repo, so we can basically programmatically look up the URL and then figure out who owns this. And that can help you basically scale the alerting and stuff. And the last one is the report disclosure. And report disclosure basically means that you can internally or publicly disclose a report that has been reported and fixed. And that is very good for, so some hackers like to brag about their skills, of course, but it's also very nice for knowledge sharing. And it also builds some sort of community around your program. We use this for showing fair treatment, so we pay the same for the same amount of, for the same type of reports. So then they can actually see that we pay the same for the same cross-scripting, for example. But the biggest impact is basically bypasses, because these hackers will go in, and then they will see, look at all reports, and then try to bypass the fixes. And that happens a lot. So, as you all know, regex is pronounced regrets, because it's quite hard to get right. And we had this special case of regex, which was basically blocking external access to internal backstage or the path _/. And the use case there was that the teams used to hide endpoints like metrics, health, and actuator behind there. So we do not really accidentally expose them. So I would say the vulnerability forecast here is cloudy and a high chance of regex bypass. So 7 days after we launched the bug bounty program, we got the bypass for internal backstage, and the dangerous character here was semicolon, right? So very advanced payload. And then they got access to the /n thing, which then disclosed secrets. Then this report was disclosed, and then in January, the year after, we got 2 new bypasses. So this time, we also had the dangerous character semicolon, but also append random string, and then do /n. So yeah, very advanced payloads again. And then the summer after, we got a new bypass of the HackerTrue one again. So yeah, and this was only done because of the report disclosure. So lessons learned here is that regex is hard and report disclosure is quite effective. And one interesting fact here is that this bug had been in production for 3 years. We had done a lot of scanning, both code and dynamic, and also had a lot of pen tests. None of these activities found this bug, but the bug bounty program found it after 7 days and kept rediscovering it for a year. So that's quite impactful, I would say. So this is the last example. It's about dependency confusion. And this is an attack that was popularized by a bug bounty hunter called Alex Birsan in 2021. And I think it's very nice when they submit research, which basically explains the attack with a meme. So in this case, the attacker will find the name of an internal package, and then try to take that package scope on the public NPM or other package systems, and then publish a version number with a higher version number. And when that happened, for example, Artifactory will get confused, and it will download the hacker package instead. And when you do that, the hacker can basically run code on wherever this is executed. So developer machines, build systems, they might even modify the library to run in production. So, of course, we had a nice central security team at the time, so they were very on top of things. So after 8 days, they have mitigated this across all the different package systems, and we have all of them. So it was a big effort. They were even so proud of the work that they created a nice blog post on how to mitigate this, called How We Protect Ourselves Against the Dependency Confusion Attack. So they basically step-by-step on how you can protect yourself. So quite nice. They even released an open source tool called Artichoke. So nice wordplay there on Artifactory and that stuff, and also we have a logo. So you can see that this timeline is not finished yet. So guess what happened? So 1.5 years later, we got a remote code execution through NPM. And that's kind of strange because we have blogged about it. We know how to fix this stuff, and we also have a tool that can automatically scan stuff. So what happened that we blogged it, built it, but we forgot to use it. So this tool was run in an ad hoc fashion, and we didn't run it automatically. So then we got this report. But the funny thing about this report was that he actually referenced our blog post in the report. So this is how we can fix this. So he used that blog post as a reference. So yeah, that was quite the burn. And after that, we of course started to run this tool 24/7. So yeah, sometimes blogging is better than creating tooling, I would say. So yeah, the bug bounty effect at FINN is that it has basically been priceless for us. So the most effective activity of them all, been a good ingredient in the AppSec program, right? So we know what to focus on. We still do all the other stuff because we want to catch the long tail of vulnerabilities. But we also believe that maybe focusing on rolling out secure defaults for the different vulnerability classes could be more effective than, for example, trying to push code scanning everywhere, because I think the effort is kind of similar. And then launching a program is easy and impactful, and every large company should have one. So if you work in a company, launch one, if it fits, of course. And then the key to bug bounty success without paying top dollar is basically just be nice and then be fast. That's all I had. Thank you for listening.